Hi, and welcome to this video on the edexcel Paper 2 foundation tier that we're going to look at. We can see it's a calculator paper. Okay, so just make sure every calculation that you do on any of the two calculator papers you're using your scientific calculator for. You don't need to show any calculations, written physical calculations down in relation to manual calculations. So if we did, for instance, 375 times 215, okay, we don't need to show 3 lines of working like that. What we do need to show is that we've written it down, that we're going to do that calculation, and we've got one answer for it. Okay, so we would type that into calculator. 375 times 215 equals 80,625. Okay, and that's a lot quicker than doing it manually. Okay, so that's going to maximize your time in the exam by doing everything on the calculator. One thing to note on the calculator, right at the top, okay, there is a little letter. Okay, you want to make sure that little letter is a D for degrees. If you've got a calculator like this, this is the Casio FX83 GTX. Okay, to access that, you press Shift, Menu, and you're looking for the angle unit, okay, which is number 2 on my calculator. And then you've got 3 different settings: degrees, radians, and gradient. Okay, you're not interested in radians or gradient. You might use radians in A level, but not in GCSE. So make sure you're set to degree, and it's got a little D at the top. So we would press number 1 there. Okay, so that's what you would do before you actually start in the exam. The other key thing, as it says on the page, we've got show all your working, answer all the questions, do something with the numbers that's in the questions. That's a really key thing. Even if you get into the exam and you're thinking, oh, I don't know how to work this one out, do something. Usually try and work on the proviso that you're going to do either add, subtract, times, or divide, depending on what the question is. Okay, as a rule of thumb, most of the times you're looking to times and divide something within that question. Okay, so it gives you a chance of getting some method marks if you don't know how to access the question or work through the question. Okay, it says diagrams are not accurately drawn unless they tell you they are, so treat it as if they're not accurately drawn. Okay, and obviously the pi button, as it says on the next one, your calculator does, if your calculator does not have a pi button, if you've got a scientific calculator, it will always have a pi button. Okay, and on this calculator, pi is on the bottom X10X button. Okay, so you'd have to press Shift and X10X to access the digit pi. Okay, if you then press equals, it will come up with just pi. And if we press S to D, that one there, okay, that's going to give me a decimal number representation for pi. Okay, which is 3.141592654 and so on. Okay. So let's get into this. Okay, the first one, 31% as a fraction. So on my calculator, all I'm going to do is I'm going to do 31. Shift percent is on the A and S button on mine. So look for the percentage key. Some of the times it's up here. It depends on your calculator. And I'm just going to press equals, and it automatically puts it into a fraction in its lowest form. So 31 over 100. So I've not had to calculate anything on there. I've just typed into my calculator exactly what's written on the screen, and it's given me my answer. Question 2. Okay, change 3 meters into centimeters. Okay, it requires you to know that 1 meter equals 100 centimeters. Okay, it is only a 1-mark question, so it only wants an answer. So I'm going to do 3 times 100. Which is going to give me 300 centimeters. Okay. Question 3. Question 3. Write the following numbers in order of size. Okay. Now again, as far as the calculator is not going to help you on this particular one, there is no calculation to do. All I'm going to do is I'm going to list them in order as they come. 1.02, 0.12, 1.20 and 0.21. Okay. My method for this would be, now you've listed them and you've got the decimal points all under each other, rub out the decimal points and then rub out any zeros that come before the number. Now, we're just looking now to say which is my smallest number we're starting with. So my smallest number, is it 102, 12, 120 or 21? Well, that's my smallest is 12, my second smallest is 21, my third smallest is 102, and my fourth smallest is 120. So that's turned it in from being something that maybe you get confused with the decimal place, okay, into being really, really straightforward. Okay, so you ignore the decimal point, rub the decimal point out, and ignore all the zeros. Okay, so just to put that back as it was, so you can see what we ignored. Remember, we've got to write them in their actual format. I can't say that 12 is the smallest number because I haven't got 12 in this bit here. So 0.12 is my smallest, second smallest 0.21, third smallest 1.02, and finally my biggest 1.20. And I'm going to write them in the original form from the question. Okay, question 4. Simplify. I've got m plus m plus m plus m. Here's my bowl. I put an m in it, then I add another, add another, add another. How many m's have I got in my bowl? I've got 4 lots of m. Next question. Part B. I've got 12 lots of p, and I'm going to cut them into 4 bowls. So, cut them into 4. Okay, and I've got 12 to put in. So I'm going to do what it says on the tin. 12 divided by 4. Okay, I'm not going to do it in my head, just going to do it on my calculator. 12 divided by 4 gives me an answer of 3. So I know that there's going to be 3 in each if I just had 12 of them. And remember, I've got 12 lots of p. So 3p plus 3p plus 3p plus 3p gives me 12p. And I just want one lot of it, which is 3p. So all I'm doing in that function is 12 divided by 4. And remember, the p comes with it. Okay, next one. Question 5. Okay. So the diagram shows a rectangle. It's 35 meters across. It's 20 meters high. On the centimeter grid below, draw an accurate scale drawing of this rectangle. Use the scale. 1 centimeter represents 5 meters. Well, if that's 35 meters and one of these squares equals 5 meters, that's what it's telling me the scale is. Okay, how many 5 meter squares goes into 35? So in my calculator, I'm going to do 35 divided by 5. 35 divided by 5, which gives me 7. And I've got 20 divided by 5, which gives me 4. So I know I need to go 7 squares that way, and I go 4 squares that way. So now I just need to draw that on my grid. Okay, so let's start at that point. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. It doesn't matter where on the grid you draw it, as long as you draw it solely on the grid. Don't go off the grid for an extra square. If you start it in the wrong place, rub it out and draw it again. So I've got 5, 10, 15, 20, 25, 30, 35. 5, 10, 15, 20. So I'm back to my original numbers at the top there, which is 20 and 35. You don't need to shade it in. If you want to shade it in, you can do. So that would be my grid. But make sure it's a strong enough pencil line or pen line to actually show that they can see the box. Okay. So, next question. So question 6. Here is a list of whole numbers from 21 to 30. From the list of whole numbers, write down a square number. So think I've got 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. Okay, and as I've said, always come back to your calculator. So if you're unsure of any of this, 1 squared, 1. Right, we've got 3 squared, so let's do 4 squared. Okay, we're giving the calculator all we're doing is writing down what we put in the calculator. 4 squared equals 16. 5 squared gives me 25. And 6 squared gives me 36. So I've written down the information that I need. I just need to now say which one falls into my range. It's going to be this one, 5 squared. So that's going to give me 25. Okay. From the list, write down a multiple of 8. Okay. So 8 plus 8 gives me 16. Plus 8 gives me 24. There we go. There's my 24. Okay. So I'm either doing 8 times table, 8, 16, 24. Right. Sometimes you'll probably find that actually writing the times table out is quicker than using the calculator. I'll leave it up to you, but on the more complicated ones, always use your calculator. Question 7. Okay, a baker has 3 bags of flour, A, B, and C. Okay, so again, thinking about this, I haven't read the rest of the question, but looking at that, I'm thinking I've got 3 things I need to compare. A, B, C. I'm thinking it may be ratio. Okay, let's have a look back. Bag A and bag B contain the same amount of flour. Okay, well, we don't know what they contain, but we do know that they equal each other. And bag C contains 940 grams of flour. In the 3 bags, there is a total of 2,500 grams of flour. So we know in total that equals 2,500. Okay, work out the amount of flour in bag A. Well, we know these two are the same. So look at what I've got in the question. I can do 2,500 take away 940. I'm going to do it in my calculator. I'm not going to do it in my head. 2,500 take away 940 gives me 1,560. And remember, these two are the same. So I need to now divide that by 2. 1,560 divided by 2 equals, divided by 2, and that gives me 780. So that equals 780, that equals 780, and that equals 940. Now, as a check, what I'm going to do is I'm going to say 780 plus 780 plus 940 equals, and that does give me 2,500. So just to check that I have got the right thing and I haven't put it into the calculator wrong, so I know that bag A contains 780 grams. So that's going to go on my answer line. Okay. One question people do ask is, if I put my answer in the question, will I still get marks for it? You'll get marks for the working of it. It depends on the examiner really, but you should get marks for the workings of it. But your answer line is down here in the question, so make sure if you put it here, you make sure you put it on the bottom answer line as well. Sometimes there is so much work in this area here that you're calculating out, they want to see what the answer line is. Okay, so make sure you put it down on the answer line as well. The units are there as well. If we put this one in my question and I haven't put it on the answer line, okay, then I need to make sure I've got that 780 grams as well, right? On this one, it already has the grams, okay, but just be careful with units. Question 8. 5 students throw a dice. They each throw the dice the same number of times. Okay, so I'm going to think about this. Student 1, student 2, student 3, student 4, student 5. They each throw the dice the same number of times. The diagram gives information about the number of times the dice lands on each number. Okay, so we've only got 1, 2, 3, 4, 5. We've got 6 outcomes. So we've got 6, 4, 5, 8, 7, and 5. So I'm going to add all of those numbers together. 6 plus 4 plus 5 plus 8 plus 7 plus 5 gives me the total. Okay, and I'm going to divide that by 1, 2, 3, 4, 5 people. That's the sum I'm going to do into the calculator. So again, if you want to use the fraction key is the one on the side there, second button down, press that one and you can type it all in. So 6 plus 4 plus 5 plus 8 plus 7 plus 5. Tab down, you come to the bottom line, I'm dividing by 5. I could put it all in one sum, or I could write the top line and then divide by 5. Yeah, so I could do 6 plus 4 plus 5 plus 8 plus 7 plus 5 equals, okay, 35, and then 35 divided by 5 gives me an answer of 7. So my answer on this one, work out how many times each student throws the dice. They throw it 7 times. And oops, that's the workings that goes with that. Okay. Question 9. Alec needs to work out the value of 2 plus 3 times 4. He writes 2 plus 3 equals 5 and 5 times 4 equals 20. So 2 plus 3 times 4 equals 20. Alec is wrong. It tells you he's wrong. Do not do the same thing he's done. Okay. It says explain why. So for a start, let's type it into the calculator. So I'm going to do 2 plus 3 times 4 equals. It gives me an answer of 14. So 2 plus 3 times 4 equals 14. Okay, so we've told them the correct answer. So what did he do first? He's done the addition first. The second part is then he's multiplied. So he's added, then he's multiplied. Thinking about BIDMAS. Okay, brackets, indices or square roots, divide, multiply, add, and subtract. Okay, remember when you do this, these two down here, okay. Remember when you do this that these two down here are done at the same time. Add and subtract are done from left to right in the sum. Okay. These two here, the divide and multiply, can be done at the same time. And again, you could go from left to right. All right. They are interchangeable in relation to when they get done. But as a rule of thumb, you can do the divide first, you can do the multiply second. Okay, these two have to be done at the same time. Okay, so if we look in this sum, we know we've got no brackets, we've got no indices, we've got no divide, we have got a multiply, so let's do that first. 3 times 4 gives 12, and then I've got 12. Remember, that's the answer to that bit. Okay, I've got 2 plus 12, which gives me my 14. Okay, now whether you have put it in words or symbols like that, he's added and then subtracted and then timesed. That's what he's done wrong. Okay, or whether you've shown the workings like this one down here to say we need to multiply first and then we're going to add. Entirely up to you which way you do it. Remember, it's only a 1 mark question. The other thing you could say, he hasn't used the rules of BIDMAS. Exactly the same answer. Hasn't used BIDMAS. It's telling the examiner you know what BIDMAS is. Okay. If it's just asking for a reason why. Sometimes that's a 2 mark question when they want to know the reason why and they want to know what the actual answer should be. Question 10. Write 17 as a fraction of 30. Okay, again, we're going to just go straight to the calculator. Put my fraction key. 17 is the numerator. Tab down as a fraction of 30. equals 17 over 30. Okay. Sometimes it will say in its simplest form. Okay. If that was 18 over 30, for instance, let's just go up and change that from a 17 to an 18, so it will simplify. Press that one, and it will give you 3/5. Okay. So again, type it into your calculator. Numerator as a fraction of denominator. Okay. N divided by 17 divided by 30. And even if you didn't want to use the fraction key, you could just put in 17 divided by 30 equals, and that will give you the same answer. Right. Now this question, question 11, reflect the shape A in the mirror line. Now again on this one, what I would suggest is that you use a piece of tracing paper, you lay it over the shape, you draw the mirror line through your tracing paper where it comes on the question, you draw around your shape, you flip it over, okay, as a reflection does, and then you redraw your shape, lifting the tracing paper up. Because I can't show that tracing paper on this particular question, what I'm going to show is an alternative method of, there's the point of that question, that shape, and we can see we are 2 squares away from the mirror line. So if we go 2 squares that way to get to my original shape, we want to go the opposite way. We're flipping it over, remember. So we're going to go 2 squares this way. So we're going to go from there 1, 2 squares down. So that's that point there. Let's call that A. Next point. Let's take this one here, and we can see we are 1, 2, 3 squares up from my mirror line. So we're going to reverse it and go 3 squares down. 1, 2, 3 squares down. And that's where it's going to be. Let's call that one B. And then let's go to the third one. And let's go that point there. And there's 1, 2, 3, 4 squares up. So we're going to go 1, 2, 3, 4 squares down. And that's going to be C. So this is going to be my C dash. And the terminology C dash just means it's the alternative point. That's B dash. And this one is A dash. So I can now draw my shape in. Okay, so we know B and C connected. It goes from B across to A, and it goes from C across to A. And there's my new shape. Now, does it ask me to label it? On this one, reflect shape A in the mirror line. It just asks me to reflect it. Sometimes it will say label it B. Okay, so I could then label that shape B. If it asks you to label it, make sure you label it. Okay, you do not need to put the points on the corners. Okay, as in like the names that we've just given that names. You don't need to do that. I've just done that to try and show where each point goes. Okay, also make sure you use a ruler when you're linking the sides up. It would be terrible to actually get it in the right place, and because you've done a curved line as opposed to a straight line, they take the mark off you. Okay. Question 12. Work out. Okay. Write all the figures on your calculator display. So, to start with, this square root is square rooting all of the values. So we're going to do square root sign first. We've got a fraction inside, so I'm going to put my fraction key. So I will end up with fraction and inside the square root. I'm then going to type the figures in. So exactly as what I see on the screen, 13.82, tab down, 4.06 equals. So that's going to, I've done no work on that, only typed it in exactly as I see it. So that's going to give me 1.844977205. I've done what it said in the tin. I've written down everything that's on my calculator screen. Okay. Now, B, give your answer to part A correct to 2 decimal places. So I need to now think, rounding I can't show on a calculator, so I'm going to take my original number and I'm going to rewrite that again, 497. Do I need to do the whole number? No, I don't. Okay, I could do past the second decimal place. So if we're thinking about that's the first, that's the second. Okay, so I need to have that bit in my answer. Okay, I don't need any more than that. So I'm going to round it at that point. First place, second place. The 4 I'm interested in. I'm not interested in any of that at all. So when writing this, I could have written 4 like that, because I need to show the bit that I'm rounded. Okay, as long as you've got the digit after it, the one that we've rounded, you'll get that that rounded mark. Okay, we know that rounds down, so that means we ignore it, and it's going to be 1.84. 1.844 is closer to 1.84 than it is 1.85. Remember, 5 and above goes up, 4 and below goes down. So 0, 1, 2, 3, 4 round down, 5, 6, 7, 8, 9 round up. RST is a straight line, so we know that this bit is a straight line. Angles on the straight line add up to 180 degrees. Work out the value of x. Well, if that equals 180 degrees, then what I'm going to do is I'm going to take that, plus that, the x that I don't know, equals 180 degrees. So that's my first line of working. X plus 75 plus 84 equals 180. Now, if you choose to want to add these together first, you can do. So on the calculator, 75 plus 84 equals 159. Again, I'm not doing it in my head, I'm doing it on the calculator. Equals 180. And now if I want to get rid of that, I want to move that the other side and do the inverse sign. It's adding at the minute. I'm going to subtract it. Because if I take away 159, I end up with 0. And I don't have to write it. So x equals, so I'm going to do 180, take away 159 in the calculator. That's the sum I'm doing. And that's going to give me 21. So x equals 21. Okay, just while I'm on this one, what I could have done is I could have said 180 take away 84 take away 75 equals x. Okay, exactly the same thing, and that's the only line of working I would need. That would give me 1 mark. The value for x gives me the second mark. Okay. So question 2 on this question. Remember, it is the second part of the question, so it relates to what we've seen before. Give a reason for your answer. Okay, we've done it, that bit there. So how can I write that down? Angles on a straight line. Oops. Straight line. Sum to, which means add up to 180 degrees. And what we've done is we've added those two together, subtracted it away from 180 to give me my answer. So it wants a verbal justification or a written justification as to why you know x equals 21. Okay. Right. Question 14. Nazima uses the graph to find out how much money she is paid for the number of hours she has worked. Okay. So I'm just going to zoom out at this point so we can see the whole question. How much money is Nazima paid for each hour she works? Now, as we can see, if we look at these lines, this line going up here, we're looking for an exact point where it crosses. So it crosses exactly at that point there. It crosses exactly at that point there where it crosses two x and y axes. Okay, exactly. So I can mark that. It says use this graph. Soon as it says use this graph, we've got to show on this graph. So we could draw a line, the dotted line up there, and then we're going to go across this way to see where it goes onto the y-axis. Okay, so we can see that that goes at 30. So 2 hours equals £30. Let's look at this one up here. Go up to that one. Okay, 4 hours equals £60. It doesn't matter which one you use, but you're looking for something that intersects exactly on a line. Okay. If we pick something like this one, 1 hour, what does that actually equal? We could work it out. It's halfway between 10 and 20. So that's going to give me £15. So I could do it that way, but you still have to show exactly where it's going to be, where you've used the graph. Okay. If I do 2 hours equals 30, I can see exactly, there's no mistake where it goes. And then I'm just going to do 30 divided by 2, gives me 15. Or 60 divided by 4 gives me 15. It's going to give me the same answer, £15 each hour, £15 per hour. Okay. Okay. B relates to the same graph. Okay. Last week, Nazima worked 36 hours. How much money did she get paid? Let's go back to the graph. We've already worked this one out. If we use the 2 hour one, okay, 2 hours is £30. So let's think about this. 2 hours equals £30. So how do I get from 2 to 36 hours? Okay. 36 divided by 2 equals 18. I'm timesing it by 18. Okay, and all I've done there is I've done the reverse. I've done 36 divided by 2. Okay, so I know it's times by 18 to get from 2 times 18 gets me 36. So I'm going to do 30 times by 18 gives me 30 times 18 equals £540. And that's my answer. Okay. Again, everything on the calculator. Question 15. Write the following fractions in order of size. Start with the smallest fraction. Okay. Very easy to fall into the trap of this one and thinking, oh, I can do this without a calculator. Right, really simple. On your calculator, fraction key, 5 divided by 8 equals, press SD, it gives you a decimal number. So we know that's 0.625. Okay, I could just type it in as a 2 divided by 3, because remember that line means divide. Gives you it as a 2/3, press it again, 0.6 with a dot over it. Okay, press it again, 0.66666. So I know that's 0.6666. Okay. Next one, 4 divided by 9. SD, 0.4 is a dot over it again, press SD again. Okay. 0.4444, and so on. And the next one, 3 divided by 5 gives me 0.6. Press SD again, it will take it back to the fraction. Okay, there's nothing stopping you cycling through these numbers. If it's recurring, it's very difficult at times to see the little dot above the 6. So you think what 2/3 was 0.6 with a dot over it. Okay, so this is 0.6. So again, let's do what we did at the start with the when we had to list the decimal numbers. We've got 0.625, 0.666, 0.444, and 0.6, nothing else after it. Okay. So get rid of the decimal points and the zeros in front of it. Okay. Make all the digits the same length long. So I'm putting in placeholders for this one. Okay, so I've made them 3 digits long each. Okay. So whether you made it 2 digits long, you'll get the same answer. Okay. So I've got 625, 666, 444, and 600. So the smallest is that one. The second one is the 600. The third one is 625. And the fourth one is 666. So again, you can see where they've come from this side. That's your third one. This one is your fourth one. This one is your first one. This one is your second one. So again, if you have a logical system of when you're writing it down, you can see where your answers have come from. You'll be able to trace it backwards. So 4/9, 3/5, 2/3, 5/8. Oops, 5/8, sorry, and then 2/3. Okay, and that's the order that we need to do them in. Remember, we are writing them smallest fraction first, and we're writing them in the original format that we had in the question. Okay. Question 16. The pie chart gives information about the colour of each car in a car park. So we've got black, white, and others. There are 135 black cars. 135. We know that value is there. Okay, work out the number of white cars. So the two things, piece of information we've got that this is 80%. Okay, and we've got that the other value, which they try to sneak in, is 90 degrees. 80 degrees, sorry. So we've got 80 degrees and we've got 90 degrees. We want to know how many white cars there are. If I could find what 1 degree is, to get from 90 to 1, I divide by 90. And then to get from 1 to 80, I times by 80. Okay, so that's just looking, how do I get from 90 degrees to 1 degree? Divided by itself, get 1. How do I get from 1 to 80? Multiply it by what I want. Okay, so we're going to do that, show that here. 90 divided by 90 equals 1. 1 times 80 gives me 80. So let's put my figures in now. We know that's 135. So 135 divide by 90. So I'm going to put it into the calculator. 135 divided by 90 gives me 1 degree. And 1 degree is going to equal 1.5 or 3/2. So let's leave it as 3/2 for now. Okay. And then I'm going to times it by 80. And that's going to give me 120. So there are 120 white cars. We've got the answer to question A. Let's go down to question B. Okay. There are 50 grey cars in the car park. Okay. A car in the car park is picked at random. What's the probability the car is grey? So probability that it is grey has to be in either percentage, decimal, or fraction. We have to write it in that format. So, do we know how many cars? Here's my car park. If we can say how many total cars are in my car park, I can do 50 divided by the total cars. Okay. Well, we did work out here that 1 degree equals 3/2 cars. Okay. We know that there are 360 degrees in a full turn or circle. Okay, so I'm going to do 3 halves. Remember that equals 1%. Okay, 1 degree, sorry. 1 degree. 1 degree. Okay, I need to get to 360. So I need to times 3/2. 3 divided by 2 times 360, which gives me 540 cars. Okay, we know there's 540 cars. We know there are 50 grey cars. So 50 over 540. Now, as a probability, that's answer is sound. It's absolutely fine to leave it like that. But 50 divided by 540, if I put it in my calculator, gives me 5/54. Okay, so again, I could divide through by a power of 10. Get rid of the zeros. Okay, and I could put 5/54. So 50 over 540 would be a correct answer, or 5/54. And that's your answer to that question. Question 17. Okay, 60 people are asked if they prefer to text or to email their friends. 38 of them, of the people, are women and the rest are men. 15 of the men prefer to email their friends. 60% of the people prefer to text their friends. Complete the frequency tree for this information. Okay, there's a lot of information all at the same time. So let's see what they tell me in this question. I'm just going to minimize that just a little. So we know this point is men to women. What do we know about that? We know the 60 people, that's that bit there. Okay, how many men have we got? There are 38 women. So we know there's 38 women here. So ignore everything else at this point and say, well, what would this missing box be here? So what sum am I going to do? 60 take away 38 equals... So 60 take away 38 equals 22. So there's 22 men. Right? So I've already got marks in the bag for that bit. We're down to the second line. 15 of the men prefer to email. So of those men, 15 prefer to email. So if I've got 22, if I take 15 away from that, that's going to give me 7 prefer to text. Okay. Third line done. One line to go. 60% of the people prefer to text their friends. Okay. So we need to know what is 60% of 60. Okay. So again, 60 times 60 shift percent equals, that gives me 36. So we know that preferring to text, 60% of 60 is 36. Okay, and we know that these two have to equal 36. So I'm going to do 36 take away 7. Take away 7 gives me 29. Okay, and now I've got one last sum to do. 38 take away 29. 38 take away 29 gives me 9 women email. Okay, and that would be the sum of that question. Question 18. Okay. The incomplete table gives some information about the lengths of the planks of wood in Ben's workshop. So a 3 meter length plank, number of planks is 5, 2.5 is 8, 2 we don't know, 1.5 is 14, and 1 meter long is 10. The total length of the planks is 92 meters. So we know it's 92 overall. Work out the number of planks of 2 meters long in Ben's workshop. So if we had 5 planks that are 3 meters long, that's going to give me 15 meters. Times 2.5 by 8, 2.5 times 8 equals, again I'm back to the calculator, don't do it in your head. Okay, 1.5 times 14 gives me 21. And 1 times 10 gives me 10. Okay, I know I've got a number here, and if I add that list together, 15 plus 20 plus 21 plus 10, that gives me 66. So if I take 92 away from 66, 92 take 66 gives me 26. Right, remember that's 26 meters. Very easy at this point to put 26 in there. These are 2 meters long. Okay, so I'm going to bring that down and do 26 divided by 2 gives me 13. So there are 13 lengths of 2 meters. Okay. So we're looking to use the sum of 92, take away what we do know, and any time where I've got a length and a number of them. If I had one length, it's 3 meters. If I've got 2 lengths and so on, it's just the 3 times table. But again, come back to using your calculator. Question 19. Okay, so again, I've got 3 different things I'm looking at. Rachel, Samina, Tom share £600 between them. Rachel get 2/5. Samina gets 1/4 of the money that's left over. Okay, so that's all of the money. So if we cut this into 5 pieces and trying to visualize this now, we know Rachel gets that bit and that bit. Okay, we've got 3/5 left. So Samina gets 1/4 of the 3/5 that is left. Okay, so we've got 1/4 of 3/5. Okay, Tom gets the rest of the money. So he's going to get 3/4 of 3/5. Okay, so hopefully you can see that we've taken those 2/5 away for Rachel. Samina gets 1/4. So if we could just imagine that we're going to cut these into 4, let's try and do it and show. If we cut that in half, okay, and then we cut it in half again and half again, Samina's going to get that part, and Tom would get that part, and that part. So I've cut that bit that I had left into 4 pieces, 4 equal pieces. Samina gets 1 and Tom gets 3. In effect, that's what we've tried to do. Okay. So let's work out the questions that's on the screen. So we've got 2/5 of 600. So the sum that I'm going to do that is 2/5 of 600. 2/5 times 600 gives me 240. So Rachel gets £240. Okay. So 1/4 times 3/5 equals, that's 3/20 of £600. And that must mean then if she's getting 3/20, okay, then Tom gets 9/20 of £600. Okay, I'm expecting that value because remember this fraction here, if we made that 20ths, she's already taken out 8/20. Okay, so 8 times 4 gives 4 times 2 gives me 8. 4 times 5 gives me 20ths. And if I had all of my money, I've got 8 plus 9 gives me 17, plus 3 gives me 20 out of 20. So that's all my parts. So 3/20 multiplied by 600 gives me 90. And 9/20 multiplied by 600 gives me 270. Okay. So let's just get rid of that one for now. So that's my split down of how much they've got using the fractions. Now it didn't tell me that I'm going to multiply fractions together. Okay, that's just the way that we've gone with that. And if we think about what we've got up here, Tom actually gets more than Rachel. We can see that. And Samina gets the smallest fraction. Okay, the smallest amount. Now, back to the question. Tom says, I would have got more money if we'd have shared the £600 equally between us. Is Tom correct? You must show how you get your answer. So again, I must show that. I've shown how much he actually gets. So Tom gets the 270. So all I've got to do is say, well, if we split that equally into 3 parts, okay, they're not equal blocks. So let's say we split that equally into 3 parts. Okay. That would be 200. That would be 200. That would be 200. So 600 divided by 3 equals 200. So Tom would get 200, whereas Tom got 270. So is Tom correct? We need a yes, no answer. No. Okay. Now, when we're thinking about this, whether we thought about this, and I've actually combined thinking about this visually so we can see what's happening at each stage, and mathematically in relation to the fractions. Okay, so remember, Rachel is just 2/5 of 600. 2/5 times 600. Samina is 1/4 of what's left. Well, if she takes 2/5 away, there's only 3/5 left. So she's 1/4 of 3/5 of 600. That would get me my 90. And Tom gets the rest of the money. Well, he's then got 3/4 of 3/5 of 600. So hopefully you can see mathematically they're your 3 calculations that you're looking to do. And that would get you Rachel having £240, Samina having £90, and Tom having 270. So it's quite a heavy question for working through that one. Okay. Question 20. Again, we've got an A and a B, but they don't relate to each other this time. So we've got c to the power of 5 divided by c to the power of 2. Okay. So c times c times c times c times c divided by c times c. So c to the power of 5 is just c times by itself 5 times. C to the power of 2 is c times itself to the power of 2 times. And remember, anything on the top will cancel anything on the bottom. So we've got 1c there that can cancel out that, 1c there that can cancel out that, and I'm left with c times c times c, which is c cubed. Looking at d to the power of 4 and then d to the power of all to the power of 3, that means I've got d to the power of 4 multiplied by d to the power of 4 multiplied by d to the power of 4. That's what it's doing. It's multiplying by itself 3 times. Okay. If I did d to the power of 4 times d to the power of 4 times d to the power of 4, I'm actually timesing. If we just took that end one off, d to the power of 4 times d to the power of 4 is d to the power of 8. 1, 2, 3, 4, 5, 6, 7, 8 times 4 more. 1, 2, 3, 4. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and you can see what I've done is that means using the law of indices, anything raised, any power raised to another power is going to give me a multiplication. So 4 times 3. So d to the power of 12 is my answer. Question 21. Write down the inequality shown on this number line. So we look to see where my circle is. Well, we know it's going to be -1. If there is only one circle, that means that my x goes in the front. So x must be, okay, there's my x. So x must be bigger than -1. Now, if that was a filled in dot, it would be bigger than or equal to. Okay, so the rules on this one is, if it's not a filled in dot, it's only the crocodile saying x must be bigger than -1. So x could be 0, 1, 2, 3, 4, 5. They're all bigger than -1. Okay, so x must be bigger than -1. Okay. So let's look at my sign, because this is the most common mistake people will make. My arrow, okay, goes that way. So we can see that if we put a 4 there, is 4 bigger than -1? Yes, it is. is 3 bigger than -1? Yes, it is. Okay, so when you're doing inequalities, you can use the arrowhead to help you with your inequality symbol. Okay. Right, on the bottom one, B, on the number line below shows the inequality. So we've got two numbers now. Okay, we can see that y is smaller than 4. Okay, and we can see that y is bigger than or equal to -3. So I need to draw two circles. So let's draw two circles for a start. There's my -3. There's my +4. So I've drawn my two circles. Okay. Is there a little line underneath it? On this one, there's not. So I'm going to leave that as a hollow dot, hollow circle. On this one, there is a line underneath it, just there. Okay. So I need to fill in the bottom dot. Okay. So if it's equal to it, if it can be equal to it, then that's going to be a filled in dot. So y lies somewhere in that range. So if I've got two values, I'm just going to connect the dots. Okay. So we know y is bigger than -3. So let's check it. -3, -2. -2 is bigger than -3. It's higher than it. Think about my temperature probe. Okay, if -3 is here, -2 is bigger than it. I'm coming out of 0. Out of negatives into towards 0. Okay, 0's up here. Let's look at the top side of that. Is y smaller than 4? Well, at this point here, y would equal 3. And 3 is smaller than 4. Smallest number eats the biggest number. Okay, so I'm happy that that meets my criteria. Do I need to write all of that in? No, I don't need to write any of this at all. Don't need to show it down there. All I need to do on this one, it just says on the number line, show the inequality. Filled in dot, because it's equal to as well. Unfilled dot, because it's not equal to. 22. Find the highest common factor of 60 and 84. Okay, if I was to do this one, my personal method would be, let's have a look at 60 and 84. Okay, 6 goes into that 10 times. They don't have to be prime factors, okay, but towards the end they will need to be prime factors. Okay, so keep going down until I get prime factors. These are primes, 2 and 5. Okay, if I think about 60 over here, I could have done 2 into 30, 2 into 15, 3 into 5. Okay, I still get the same answer. It doesn't matter. 2, 2, 3, 5, 2, 2, 3, 5. Okay, it doesn't matter which way you divide it now. Okay, 84. 2 goes into it 42 times. That's a prime. 2 goes into it 21 times. 2 goes into it. 3 goes into it 7 times. Okay, so if I want the highest common factor, right, I want the highest number that's the same. So I've got 2 times 2 times 3 times 5, that's 60. And for 84, I've got 2 times 2 times 3 times 7. Well, those three are the same. So that's my highest common factors. 2 times 2 is 4. 4 times 3 is 12. So my highest common factor is 12. 2 times 2 is 4. 4 times 3 is 12. So 12 times 7 gives me 84, and 12 times 5 gives me 60. Now, if you struggle on highest common factor, you could employ this method. This is the simplest method I've come across. Okay, and to try and explain it, here's my 60, here's my 84. Think of a number, the biggest number you can think of that's going to go into both of those. Let's say I'm going to divide it by 2, both even numbers. 2 times what gives me 60? 2 times 30. 2 times what? Well, that's going to give me 42. Okay. What goes into both of those? Well, 2 will go into it again. 2 goes into that 15 times. 2 goes into that 21 times. What goes into 15 and 21? 2 is not going to. No even number will. So let's try 3. 3 goes into that 5 times. 3 goes into that 7 times. and we've got the same values. Now everything that's on this side multiply together, and that gives you my highest common factor. So times those together gives me my highest common factor. Okay. The benefit of this is, if we now look at our value there, what I've got left, okay, I've got 2 times 2 times 3, that's my highest common factor. And I'd be able to find my lowest common multiple by timesing 5 and 7. So I'm timesing those two on top of my highest common factor. So I could do 12 times 5 times 7 would give me my lowest common multiple. Okay, so we're going to try this method on the next question. So we've got find the lowest common multiple of 24 and 40. So here's my ladder, here's my 24, here's my 40. It doesn't matter. If you can see a big number that will go into it, then we can use that. We don't need to just use 2 each time. Okay, so 2 goes into that 12 times, 2 goes into that 20 times. I can divide by 2 again. Okay, 2 goes into that 6 times, 2 goes into that 10 times. I can divide by 2 again. 2 goes into that 3 times, 2 goes into that 5 times. Okay, nothing will divide into that anymore. So my highest common factor are these ones times together. 2 times 2 times 2 gives me 8. And then I'm going to times 3 and times 5. 3 times 5 is 15. Remember, it's a calculator question. Okay, 3 times 5 times 8 equals 120. So remember, I've summed that to be my highest common factor. Multiplied that, sorry, to get my highest common factor. And the product of my highest common factor with my 2 remaining factors, 3 and 5, will give me 120. Okay. Number 23. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of the journey. So the first 15 minutes, so we can see 5 minutes, 10 minutes, 15, 20, 25, 30, 35, 40, 45, 50. So overall my graph is 50 minutes long. Look at the increments on the kilometers. So that's going to be 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay. Work out Sam's speed in kilometers per hour for the first 15 minutes of his journey. Well, using that graph, in 15 minutes, he travels 20k. Okay, 20 kilometers. So we're going to use our speed, distance, time graph. We know the time, 15 minutes. We know the distance. We need to know the speed. So ignore that one off, cover that up, and we've got distance divided by time. Distance divided by time. Remember, this is times on the bottom, and then divide if it's coming from the top. So distance divided by time. That's what we're looking to do. My distance is 20. My time is 15 minutes. So I'm going to do 20 divided by 15 gives me 4/3. Okay, so I'm going to leave it as a fraction because it's 1.333333. So that gives me 4/3. And think what we're doing. This is kilometers, minutes. We want it kilometers per hour. Okay. So kilometers per minute. How do I get from minutes to hours? I need to times it by 60. Okay, there are 60 minutes in an hour. So I'm going to times 4/3 by 60, and that gives me 80 kilometers per hour. Okay. If you wanted to find out and think that we could simplify this here, well, 15 minutes is 1/4 of an hour. Okay. I could just change the colour. I could do 20 kilometers divide by 1/4. Okay. So on my calculator, fraction key 20 divide by fraction, and the denominator of there is 1/4, and that gives you the same thing. That gives you 80. Now, it's not mathematically correct to put a fraction as the denominator of a fraction. Okay. Mathematically correct, it would be more beneficial to put it like 0.25. Okay, because it's a value we can use. But your calculator will work it out anyway. Okay, so like I say, use your calculator. Right, question B. Again, it relates to the same graph. At 10:15, Sam stops for 10 minutes. Okay, so he stopped. He's not going any distance at all for 10 minutes. 5, 10. So there he has stopped. Okay. Next. He then drives for 20 minutes at a speed of 75 kilometers an hour. On the grid, show his journey. Well, if he's going 75 kilometers an hour, okay, it doesn't say he returns home. Okay, it just says he drives. So it's a slightly ambiguous question. So let's say we're going 75 kilometers per hour. So if he travelled for an hour, he would be going 75 kilometers. Okay. So 75 kilometers in 1 hour. Well, what about if he went half an hour? Okay. Half an hour, we would have to half that divided by 2. We want to do 20 minutes. So think of the link between 60 minutes and an hour. So 1 hour, remember that's 60 minutes. So we're going to convert that there. If I wanted to go to 20 minutes, you've divided it by 3. So divide 75 by 3, 25, 50, 75, and again use your calculator. 75 divided by 3 gives me 25. He's gone 25 kilometers. Okay, we can see he's here, so it now makes a little bit more sense. He can't go 25 kilometers because he's only 25 kilometers from he's only 20 kilometers from home. So we're going to go further away, 25 kilometers. So we're going to go in 20 minutes, 5, 10, 15, 20 minutes. And we've gone 5, 10, 15, 20, 25 kilometers. Okay, and then we're going to just draw that line. Okay. And we can see it's slightly shallower. It's not quite as steep as the 80 kilometers an hour. He's going a little bit slower. So the whole of this bottom bit is just trying to draw that on that grid. So think we've gone 5, 10, 15, 20 minutes away. So it's going to be somewhere on this line here. Okay. And then we just got to work that out. 20 minutes is 1/3 of an hour divided by 3. 25 is 1/3 of 75. Okay. Question for 24. Okay. 2-part question again. 2 marks for each part. Okay. With the table of values, really simple in the sense of when you type it into your calculator, you are typing in this part, and all you are doing whenever there is an X, you put a set of brackets. So you're going to type into your calculator bracket, bracket squared minus 2 bracket, bracket plus 2. That's all you're going to type in. Okay, so I'm just going to type that in now. Bracket, close bracket, squared minus 2 bracket, bracket plus 2. Okay, so you start off with that value. Now what you're going to do is you are going to substitute each of these values in turn inside the brackets. Okay, so on the first one, I'm going to show you on the calculator. I go inside the brackets, tabbing left till I get inside the brackets. So I'm going to put 1 in there, and then come to the next one and put 1 in there and press equals. That's going to give me an answer of 1. 1 squared minus 2 plus 2 is going to give me just 1. Next one, tab back in, exactly the same thing. This time I'm going to change it for 2. So delete 2, tab right until I get to the 1, delete 2. That's going to give me an answer of 2. Now I'm going to do the same thing for 4, tab back in, delete 4, delete 4. That gives me 10. And if you see here, you should see a pattern. 2, 2, 5. That's going to be 5, 10, 10. Okay, it is a quadratic, and I'm expecting my graph to look something like that. It's going to be symmetrical. Okay, but let's just check. Tab backwards into there. Okay, and then we're going to look at that one and delete. We need to put -1. Go to the next part where the 4 is. This time delete and put -1 equals. And that gives you 5. You can see that 5 there. Okay. So I've got my 2 marks for that one. Okay, and all I've done is substituted it in. Let me just zoom out a little. Okay, so we're now going to plot these points on my graph. So we've got, let's start with 0. So when x equals 0, y equals 2. So it's going to be that point there. When x equals 1, y equals 1. When x equals 2, y equals 2. When x equals 3, y equals 5. So I'm going to go halfway between 4 and 6. Okay, when x equals 4, y equals 10. And then going down to the negatives, when y equals -1, x equals 5. When x equals -2, x equals 10. Okay, so I've plotted all my points on there, and I now just need to connect them up using a nice smooth curve. Now, as much as I can, I'm going to try and do this in one motion. If you get down to the bottom and you have to redo it, not a problem. Okay, you can see I'm slightly off with that line. Okay, so don't be afraid to redo it. Okay, and then rub out the first one that you did that was wrong. Okay, we want to have a nice smooth curve. Something like that will get you the marks. All right. Now, remember that these lines will go on, keep going on until it goes off your graph. So you won't lose marks if you stop at the top point. But remember, these lines will go on because this line will go on forever. Okay. In the grand scheme of things. Now, we've got our 4 marks for this one. We've now got a part C to the question. Okay, and it says, use your graph. So I've got to use this graph we've just done to find estimates of the solutions for this. Okay, the solutions for this graph. Now, you can see my graph here is this graph, but the difference is that says it equals 4. Okay. So it says that's what y equals at the minute. Y equals 4. So when we're coming down here, what does that equal when y equals 4? So if I draw my line of where y is going to be equal to 4, so let's just put this one on. Let's say y equals 4 at this point. So let me draw a line across when y equals 4. Remember, that's going to be a horizontal line. Remember, because that equals y. So y equals 4, which equals that value, that graph. So we're looking for 2 points. The first point we're looking for is when it crosses that new line just there and that new line just there. So they're my 2 solutions. Okay. So when y equals 4, at that line, okay, what are my solutions? Find estimates. Well, my estimates down here is going to be, well, roughly, using my graph, we could say 0, 1, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 little squares. So let's say that one there, so that's going to be minus 0.7. And on this one coming down here, okay, that's going to be 2.1, 2, 3, 4, 5, 6, 7, 2.7. So it's going to be minus 0.7 or 2.7. And they're my solutions. So the solutions are where the line will cross the axis given. Now I will say at this point, and it was quite a crafty question, okay, the XY grid, okay, so there's my XY. Usually on a quadratic, which this one is, okay, the quadratic will cross the x-axis like that, curve and go back up again. So my two solutions will be this point here and this point here. You can see with this graph, it never actually gets down to cutting the x-axis. Okay, so it's not actually got any physical solutions, but that's why they've put this little bit in here, which says, well, when y equals 4 though, we've had to draw this line on here of y equal 4, okay, to give ourselves the two solutions that we found. All right, so it's quite a crafty little question. So you're using that value of y equals x squared minus 2x plus 2, and then we're making y equal 4, so we're actually lifting that x-axis up, and we're saying, well, when y equals 4, what would those solutions be? Question 25. Here is a right angle triangle. Okay, the shaded shape below is made up of two of these triangles. Okay, work out the perimeter of the shaded shape. Give your answer to three significant figures. Now, first thing I'm going to do is I'm going to go down and I'm going to say how many marks is it? It's 4 marks. Okay, so I'm going to expect 3 pieces of working and 1 answer. So what do I know? What do I see? I can see that it's a right angle triangle. So I'm thinking two things. I'm thinking Pythagoras or I'm thinking trigonometry. Okay, I haven't got any other angles in there, but I have got two sides that I know, so I know it's going to be Pythagoras. So a squared plus b squared equals c squared. Remember that the one opposite my right angle is always my longest side. My rule of thumb, you don't have to use it, but is that the smallest one I always call A and the middle one I always call B. So let's say if I can find the square of A and the square of B, that's going to equal the square of C. So 8 squared plus 10 squared equals c squared. Okay, so remember that's my bottom question just here. Bottom triangle. This is the one we're doing. Okay, 8 squared gives me 64. 10 squared gives me 100. That gives me 164 equals c squared. I want to know the square root of c squared because that's going to give me c. So the square root of 164 is going to eat the square root of that. And the square root of 164, 164 square rooted. Gives me 2 third 41. If I press SD, it'll give me 12.806244847. Okay, so 2 third 41 equals that value. Okay, now if we think about the next triangle, we know the base of it is still 10. So we know that this value, 2 third 41. So this value has to be 2 third 41 because it's two of these triangles. Okay. So that part is 10. So I need to find out what's that little bit if I want the perimeter. Okay. Because let's draw the perimeter on. We've got 8 plus 8 plus 10 plus that bit, which is 2 surd 41, plus that bit there. So I need to find that bit there. That's the difficult part, if you like. Well, I know the base from there to there is 10. And I know the top bit from there to there, the whole length, is 2 surd 41. So 2 surd 41. If I take away the 10 away from it, that will give me the perimeter. And just give me that little bit. So I've got 8 plus 8 plus 10 plus 2 surd 41 tab to the right to come outside of the surd plus, okay, and then I'm going to put in brackets what I've just written on the screen. So I'm going to put, I've got 2 surd 41 tab to come out of the surd minus 10. Okay, you can see there on the screen, hopefully, that that's what I'm going to put in for my answer. Okay, so my answer will be 16 plus 4 surd 41. Okay, 16 plus 4 surd 41. Now, that is not an exact answer. Okay, I can't round that because it's not in decimal places or an actual number. So if I press SD, I end up with 41.61 and a load of odd numbers. So I'm just going to write that down. 41.612499695, and I'm going to round that to 1, 2, 3 significant figures. So I'm interested in what the 1 does. It's going to round down, so that's going to give me 41.6. We're in millimeters. Perimeter, I'm walking around the outside of it, so it's going to be a linear measurement. So, and it's done to 3 significant figures, and that would be my answer. Okay, I'm just going to come back to the screen on this one. Remember, okay, I calculated that in there. If I'm not careful when I go sideways, okay, and let's say I delete that out, I can very easily, okay, put the minus 10 underneath the surd. So it's very easy to actually get that so that I'm getting the wrong answer. So always when you're inside a surd or inside a fraction, make sure you tab to the right to get your calculator to move outside of that function. Okay, just something to be aware of. So 41.6 millimeters is the answer to that question. Okay, almost there. We've got 28 questions on this paper, so we're on question 26. ABC is a right angle triangle. Work out the length B to C. So we want to know what length is it between those two measurements. So right angle triangle, Pythag, or trig. Okay, do I have 2 sides that I know? No. Can't do Pythagoras. It's got to be trigonometry. So what do I know? That's my hypotenuse. They give me this angle, so that's my opposite. So this must be my adjacent. What do they want me to find? Okay, they want me to find this measurement here, okay, which is B to C. So I want to find the opposite. So Toa. Okay, I know the adjacent. I want to find the opposite. I'm not interested in the hypotenuse. Don't want the hypotenuse. So straight away, I'm led to it's going to be Toa. Draw my triangle, tangent, opposite, adjacent, same as my speed distance time. So it's always the first one is the bottom left, middle one is the top, and the end one is the bottom right. Okay, same thing applies. Times, divide, divide. So if we can get into the process of using these triangles, we can say exactly what the function I'm going to type into my calculator is going to be. I want to find a side, so it's just tan. So tan of the angle, which is tan of 56, equals opposite, which I don't know, divide by adjacent. That's the one I want to do. I want to find. Okay, divide by the adjacent. Okay, so if I cover the opposite up, I'm going to times tan 56 times the adjacent, because to remove that from there, times by a leaves me O on its own. So I'm going to do 12 times tan 56 equals. And that's what I'm going to put in my calculator. So 12 times tan 56. Remember to close your bracket on the when you put your tan in. And that gives me 17.79073.162. We want it to one decimal place. What effect is the 9 going to have? It's actually going to round that up by a point. So 17.8 would be my answer. Okay. And again, it tells you exactly what, let's say if you use these triangles, cover that up, that's my function I'm putting into the calculator. So with what I did 12 times tan 56, let's go back into it and do it the other way around. Remember, these are interchangeable. Okay, so times 12. Doesn't matter which way around you do it, you still get the same answer. Okay, PQR is a right angle triangle. Pythag, trig. Okay, work out the size of the angle. Well, Pythagoras isn't going to tell me anything about angles at all. So I'm after the trigonometric ratio. So hypotenuse, there's my angle, that's my opposite, there's my adjacent. So I don't know the opposite, and I don't want to know the opposite. So again, so toa. I don't know the opposite. I don't know the opposite. I'm having to use cos of x equals, here's my triangle, cos adjacent hypotenuse. Adjacent divided by hypotenuse. So the adjacent I know is 15. The hypotenuse I know is 18. I want x on its own. Whenever I need to find an angle, I do the cos of the -1. So that's what I'm going to type into my calculator. So I do shift cos, fraction key, 15, tab down, 18, close bracket. So I end up with cos -1, 15 over 18 equals. And that's going to give me 33.55730.976. Again, I want it to one decimal place. Again, they want me to round it up. So 33.6 degrees. Now, what I will say here, top tip, okay? Even if you can't access any of this, you don't know what ratio to use, doesn't matter. In any way, shape or form, you can get the 1 mark for the rounding on both questions by just putting any random number. Say we said it's 45.689 degrees. We put a random number down and we go, well, 1 decimal place, that's going to round it up. Make sure you're showing you're rounding it up. Okay, if it leaves the same, you stand less chance of getting that mark. But so 45.6 to 1 decimal place degrees, right, is totally incorrect, totally wrong, but you've still shown them that you can round it, so you accessing that rounding mark if that's available in the question. Okay, question 27. I need to solve this one. So x squared minus 7x minus 18 equals 0. We know it's a quadratic. We know it's going to be a graph that looks something like that. What else do we know? We know that there's two factors that times together to make that, and there's same two factors must add to make that one. Okay. The only way, as soon as we see this and it says solve, we know it equals 0, and we know that it's got to be 2 brackets starting off with an x. X times x gives me x squared. So what two numbers will times together to make 18 and add together to make -7? So I've got 1 and 18, I've got 2 and 9, I've got 3 and 6, and that's all of my factors. straight away that's coming to mind because I think 2 and 9, how do I make negative 7 out of 2 and 9? Well, if I did 2 take away 9, it would give me negative 7. So my 2 goes in one bracket, my negative 9 goes in another bracket, and they're my two solutions. Okay, so I've got x plus 2 equals 0, or x minus 9 equals 0. Because remember, these two brackets are times together, and anything multiplied by 0 would give me 0. So what's x equal if I add 2 to it and it gives me 0? X must equal negative 2. So x equals negative 2. What does x equal if I take away 9 and it still gives me 0? X must equal positive 9. Okay. Now the way you're looking to do this one is whatever the value of your factor is, you're doing the inverse value for your solution. Okay, all you're doing is moving it across the other side of the equal sign by doing the inverse function. So x equals negative 2 or positive 9. And that's question 27. Last question. Okay, so in a sale, the normal price of a boat is reduced by 15%. The sale price of the boat is 272,000. Okay, work out the normal price of the boat. So let's think it starts off at 100%. It's reduced by 15%. So that gives me 85%. 272,000 equals 85% of the original price. Okay, so can we find what 1% would be? Get from there to there, you divide by 85. Let's do the same thing this side. Divide by 85. So in the calculator, 272,000 divide by 85 equals, gives me £3,200 is 1% of the value. Okay, is 1%. So what would 100% be? Go from there and multiply it by 100. Gives me the start price, the total price, 100%. So times that by 100. £3,200 times by 100 gives me £320,000. And that's my answer. Now, you could say, you know, the link between these two, thinking of what 15% of reduced it by 15%. The worst thing or the most common thing, sorry, that happens here is people find 15% of that and add it on. You can't do that because 15% of 272,000 is smaller than 15% of £320,000. Okay, and usually if we did that, okay, and I will just show it on the calculator. We've got 272,000, okay, times 15%. That gives me 40,800, and I've got 272,000, 312,800. It's not as nice a figure, not as nice a sum as £320,000. Okay, so you can calculate it, but that would be totally wrong. Okay, it isn't fine 15% of this. You've got to think, how much is it actually worth now? It starts up at 100%. It's reduced by 15. It's gone down by 15%. That means now the value of it is 85%. If you can get that bit, all the rest follows through. Okay, brilliant. So hopefully that was helpful. Okay, see how you get on, and good luck.